Hello, my name is Tyler Sabad and this is my ENME 351 Lab 9. For this project, I have created a mini-scale soccer simulation in which we can detect if a goal was achieved or not. Here is the setup for my circuit, which we will be able to see in greater depth later on. But for demonstration purposes, here is what happens. As you can see, when running the processing code, we get a generic detection window of whether or not there is a goal in this region of the zone. Now, as you can see, upon placing the soccer ball, the ball is kicked and into the goal, in which case a goal detection is created. Now, as we remove the ball, no goal is detected. Now we can dive into the circuit. As you can see, when I remove this soccer simulational stand, my circuit is somewhat generic, but consists of three main components. First, two photoresistors here near my fingers, which are then placed inside of each hole on the simulation, and a micro servo. Together, this allows for sensing and actuation between my circuit for the ball to be kicked and scored, which is then reflected on the processing window as demonstrated earlier. Diving into my code, first we look at the Arduino code. In this code, in the global variables, we set up five variables. First, both photocells as pin 1 or photocell 1 and photocell 2 in pins A0 and A1, and the servo pin as a PWM pin 9. Next, two thresholds are defined at variable values which can be changed throughout the code given the light of the room. Next, in the setup, we set the servo as an output and open the serial communication at 9600 baud. This leads us to the loop. In the loop, we create two values, sensor 1 and sensor 2 as floats, which read the photocell pin values throughout the circuit. This gives us two values for each photocell, which we can use in relation with the thresholds defined earlier. The next section of the code here is commented out, however, is uncommented out, therefore in the code, when prior to testing to check the sensitivity of the light of the room. So with this commented out, we serial print the light functions or the light values for both light sensors, and we are able to see that and then change these thresholds to higher or lower values if needed, depending on the lighting of the room. Next, we enter the first if statement for the first light sensor, which would be the light sensor underneath of the servo. If the light sensor is less than the threshold predefined, the servo will become active and therefore kick the ball. As you can see here, we create a PWM pulse using start time with a millis function and then a high to low ratio given a certain number of microseconds. We do the exact same thing to revert the servo to its original position with a different level of intensity for the PWM pulse. Finally, an if-else statement is used for the threshold of sensor 2, which is the goal sensor. If the sensor reads a value greater than the threshold or equal to, no goal is printed because there is nothing in the goal. If not, meaning that there is something in the goal, which would be the sensor 2 is less than the threshold, then goal is printed. This is the entirety of my Arduino code. Next, we'll take a look at my processing code. Using generic things that we learned throughout the semester, we have a setup here at the beginning, which creates a 512 by 512 pixel window, along with importing a confetti image and reading the serial output of my Arduino code. From here, we set the baud rate to 9600 and choose my port, which for me is 1. And then, like I said, we upload the confetti image, which I have in a data folder in the same folder as my processing code. Moving on to the void draw, we set the background to white and we move into an if statement where if the serial monitor from the Arduino code outputs goal, then we will enter this function where the confetti image is imported, as you can see here, to the middle of the screen, with the text set to black still, making sure that we read the words goal. You will also notice a void serial event function at the bottom. This function allows it so that as the serial output is received from the processing code, any changes in the output will change the processing output. Therefore, when a goal is detected, the processing code will read a goal versus no goal. Thank you for listening to my Lab 9 project. I hope you enjoy.